close this unit with a whole bunch of POs. Now that we've kind of got the logistics of graphing, what functions are, we talk about function notation, things like that, we're going to start to really get into what makes a graph relation, what we can interpret from it, what we can use it for, everything like that. So in CO19, we learned that slope and linear functions are connected. A linear function will have slope, and if a function has slope, it's a linear function, right? So it goes both ways, okay? We've defined slope before, but we're going to define it a little bit differently today, okay? Slope describes how a line moves across the coordinate plane. How a line moves across the coordinate plane. Okay? And a common phrase you've heard, I'm sure before, with slope is rise over run. Right? Really what rise over run is describing is that change in y. Do you want to come up here?
What?
Lucas? Yeah. What are you talking about? Do you want to come up here? Oh, okay. That rise over run describes how that line moves along the y-axis, the change in y, compared to how the line moves across the x-axis, that change in x. But to shorten it, we use rise over run. Okay? Just remember that y is on top, rise and y's. Right? Rise, y's. So if you're given a relation that's been graphed on the coordinate plane, okay, we're looking for that change in y or change in x. Last year you probably drew some triangles on it to say, how do you get from one point to the next point? Okay? We don't want to try and calculate slope unless it's passing through a corner of the squares. Like we wouldn't go from here to here, right? Because it's passing through the side of one of the squares on the grid, not a corner. So we want to look for two ordered pairs that are on corners. And it's also important to note, we read a graph from left to right. Right? Not from right to left. It's like words on a page. Left to right. So to get from this first point on the left to the first point on the right, how far do we have to rise? Do we go up, we go down, and how far do we go, Claire?
We go up 2.
Go up 2, right? This is a rise of positive 2. That's the change in y. It's going from -1 on the y-axis to +1 on the y-axis. That's a change of positive 2. And then how far do we got to go over? 3. From -2 to +1, that's a change of 3. So our slope is going to be +2 over +3. Okay? And what makes this linear is that we can do that slope again and end up back on the line. If we start at this point and we go up 2 and over 3, boom, we're on the line again. Right? If we had started down here and gone up 2 and over 3, we're at that point again. It's like a staircase. Okay? And that's why it's important that that change in y over change in x is constant. That's what makes it linear. The slope will not change with a line. Right? The next one. Again, going from left to right. So starting at this point, ending at that point, what's our rise? Which direction, up or down, and how far do we go? Damien.
Oh, you go down 2.
Down 2. How does that change things here? Negative 2, right? We're going down the y-axis. From 4 to 2 is a change of down 2. And then to get over to that point, we're going from 2 to 6 on the x-axis. What's that change?
What slope is.
We're not there yet. I just want to know what the change is. That horizontal change.
Oh, no.
Huh?
Frustration.
Oh. +4. +4, right? From 2 to 6 is +4. So our slope, rise over run, -2 over 4. I heard someone say you need to simplify this, which you do, and it becomes, Lucas?
Well,
-1 over 2, right?
It intersects before that on the line.
It does, at -1 over 2. -1 over 2, right? So you don't need to use adjacent points or points that are right next to each other to find the slope. If you don't, like we did here, we kind of skipped over one, right? We went from here to here, we skipped that point. When you simplify the slope, then you get back to that one. Okay, so all you need are 2 points on the line. It doesn't matter where they are as long as they're passing through corners. Even if you skip one, like we did here, you still end up with the same base slope because sloping a fraction, you can simplify it. Okay? Is this coming back from last year a little bit?
Yes.
Okay, any questions that folks have? Because last year this was 2 different objectives, finding slope from a graph and then finding slope using the formula. Since you've done both of these before, now we combine them. What is, we'll capture this, we'll put that up there.
Selfie.
What is the slope formula? This is a key point, which means it can go on a help sheet. Addie? That's slope intercept form.
Dang it.
Slope intercept form, but what is the slope formula? Fiona?
y1 minus y2 over x1 minus
y1 minus y2 over x1
x2.
minus x2. You could also flip that around and have y2 minus y1 over x2 minus x1. That doesn't make a difference. As long as you go the same direction each time, then you're perfectly fine. Okay? But why does this formula work? Remember what the definition of slope is. The change in y over change in x. What operation does that word change mean?
Subtracting.
Subtraction. Okay? So by definition, change in y over change in x, we're looking at the difference between the y values and the difference between the x's. So, you go take your ordered pairs, you label them first x, first y, second x, second y. Right? They're not powers, they're not raised numbers, they're lowered, so it's like first and second. And then you use the formula. y1 minus y2, 7 minus 10, over x1 minus x2, 3 minus 5. What do we get? Numerator?
3.
Negative 3 over negative 2,
So 3, 2.
which simplifies to be positive 3 over positive 2. Right?
I did it backwards.
Now, if you did it the other way, y2 minus y1 over x2 minus x1, your fraction looks like this. 10 minus 7 over 5 minus 3, which is 3 over 2. You get the same answer either way. Just one of them, you have to simplify a little bit first.
What?
Okay? So as long as you go the same direction, 2 and 1, 2 and 1, or 1 and 2, 1 and 2, it doesn't matter which one comes first. Okay? It doesn't matter which one comes first. What you can't do would be something like, 7 minus 10 over 5 minus 3. That would not work. Okay? That'd be going 1 minus 2 and 2 minus 1. Okay? The next one, do it yourself. x1, y1, x2, and y2. Use the formula, simplify it. See what we come up with. While you're working, also a quick reminder, Khan Academy is due tonight. So if you need to prioritize between this assignment and Khan, this is not due till Monday. Khan is due tonight, so.
Also for
Yeah.
us.
You're welcome.
You go girl.
Well, I have drama. I can't get internet.
That's why that week,
You get home from drama at 6.
it's not due until 11:59 p.m. tonight. You literally have the entire day. Will, what'd you get for your slope? Negative 3 over 4 is what Will got. Do we have a second on that? Okay.
Wait, no. I got 3 over negative 4.
Oh, okay. So if you
That's not
do,
possible, James.
yes, it is possible. Just hold on before you start jumping all over again. It is possible. If you do, folks, Matt. If you do y1 minus y2, you got 4 minus negative 8 over x1 minus x2, negative 6 minus 10. This minus a negative, remember that's actually addition. When you subtract a negative number, it's the same as addition. So this would be positive 12. And negative 6 minus 10 is a negative 16, which, when you do reduce this, does give you 3 over negative 4. So that's not a wrong answer. Okay? When you're dealing with a fraction and negative signs, all three of these things are the same value. It does not matter where that negative sign goes. Now typically, you'll see this one most commonly. You'll see this one quite commonly also. Not so much that one, but it's not a wrong answer. Okay? It's not a wrong answer. It is the same value, right? If you did it y2 minus y1, your equation looks like negative 8 minus 4 over 10 minus negative 6. And that's where you get negative 12 in the numerator, positive 16 in the denominator, which is where you get negative 3 over 4 as an answer. Okay? So that's why either way works, because those values, the way fractions work, those values are the same thing. If you were to divide 3 by negative 4, you get negative 0.75. If you took negative 3 divided by 4, you'd get negative 0.75. Right? The values are the same. So, the last one, do it quickly. We'll go over answers, and then I'm going to let you work on your homework for the rest of the time. What do you think the most common mistake is that people make when using the slope formula? Just to guess. Maybe this is you last year. Fiona? Or sorry, not Fiona. Olivia?
Oh, they put the x as the numerator and
Right.
y as the denominator.
People put their x's on top. Okay? Which I get why. Ordered pairs, x's always come first. But the definition of slope is rise over run. The y's are the numerator, the x's are the denominator. Who is bold, brave, believes in themselves? What did you come up with? Henry?
1 over 25.
Positive or negative?
Positive.
Do we agree?
Yes.
I got it as negative.
x1, y1, x2, and y2. Let's kind of hash this out.
Oh, never mind.
If you do y1 minus y2 or x1 minus x2, negative 6 minus negative 5, negative 11 minus 14, negative 6 plus 5 is a negative 1, negative 11 minus 14 is a negative 25, but a negative divided by a negative is a
Positive.
positive. And so 1 over 25 is the answer. Okay? If you did the other way, you would have gotten positive 1 and positive 25. Right? And so I want to go back just a little bit before you start working on your homework about this whole fraction thing. Okay? We got negative 1 over 2 as our slope for this one, right? And we showed that if we went down 1 and over 2, we got back on the line again. If you wrote it the other way, if you wrote your 1 as positive and your 2 as negative, it still works, right? It's going backwards, but it still works. If we start at this point here, and our rise is positive 1, that means we're going up the y-axis. If our run is negative, which direction are we going? Left, right? Because going left on the x-axis is moving negative. And so going left too, we do still end up back on the line again, right? So this slope here is 1 over negative 2. This slope here is negative 1 over 2. We see they're the same value, but because we read a graph from left to right, this is typically what you'll see, right? To make that run positive to the right. But this is not wrong. It's just kind of less used. So there's your explanation on that. Lucas.
Oh, shoot.
Very well. Okay. Your assignment for Monday is these two graphs here. Write the slope of the line. Don't worry that I'm not giving you ordered pairs here. Remember what you're looking for. You're looking for where the line passes through corners, right? Make your own points. It's based on what I'm trying to say here, right? Make your own points. Where does that line pass through a corner? Not the side of a square, a corner, okay? And then you've got 6 of them to use the formula. The brain busters here, write 2 ordered pairs with a slope of 2/3. Basically, you're looking for, when you use that formula, what are 2 values that when you subtract them will give you 2? That's your rise. And then what are 2 x values that when you subtract them will give you 3? And then what ordered pairs could you make that would fit that? So you're working backwards. I give you the slope, you're figuring out what ordered pairs are needed to give you a change of 2 for the y or give you a change of 3 for the x. So it's going backwards here. Then review at the bottom, relation and of course function notation, just because the more we practice that, the better. Lucas.
Okay, so for the graph on the right,
Yes.
couldn't you go up instead of down since the graph continues?
Up instead of down.
Couldn't you go up and to the right because
That's the way you should go,
the
yeah.
graph continues?
Because that's reading a graph from left to right, yeah. So yes.
Like if you don't have enough room in the graph, so you have to go down.
You just have to find a second point. No, like once you find your second point, looking for where this passes through a corner, not 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 a corner, boom! Right? Once you find that second point, now you can go from left to right. Right? Okay. Questions, comments, concerns, complaints, columns, congratulations, criticisms on this. Don't forget about con that is due tonight. Yes? You're welcome. All right, that's how you math.
Don't forget to try.